sign chart. Look at that last example that we did yesterday. We're looking at the signs of the first derivative because we don't have a graph. All we have is an equation. The question was, how do we mark, how do we separate, how do we put into or separate into intervals the domain of a function? We said critical numbers, which are 0 or DNEs of the first derivative, pitchfork. There's one other thing we have to include. Discontinuities. We have to look for domain problems or continuous problems, right? We have to look for domain problems or continuous problems, and we have to include critical numbers, but that's the second step. The very first step is, are there any discontinuities? Now, did he have any? X to the fourth minus 10x squared plus 9? No. So he didn't have any discontinuities. It was no big deal. And question, guys, why was the number line going forever right and forever left? What's the number line signify? An infinite what? Domain. Domain. So if this domain is restricted, your number line is restricted. Quick heads up, maybe we'll see an example of that one today. I know there was one in your homework for sure. Let me quickly make sure my volume is turned up on my computer. Otherwise the recording doesn't work so well. He is. Let me double check my phone's turned up. He is. Perfect. What was that green thing at the very bottom of the page? I forgot that we went ahead a little bit. What did you do at the very, very end of yesterday?
Something in the fourth one day. Those are the critical numbers.
It's a W graph because we know kind of what a quartic looks like. And we saw this whole like decreasing, increasing, decreasing, increasing thing, right? And so as we were looking at it, I was like, hey, is there going to be any relative extrema? You guys actually told me, I don't even think I told you anything. I was just kind of hinting, like, look at the graph. You were able to tell me there's a relative min here, a relative min here, and a relative max there. Now, there is actually, now, I'm going to show you the graph real quick. I think we saw it yesterday. Oh, it kind of makes sense. We have a relative min. If we were to actually plug it in our calculator, it would be root 5. It's a little bit past negative 2. And it would be positive root 5, a little bit past positive 2. But our point wasn't to graph quite yet. But there is something to help us with what we were talking about at the very, very, very end of yesterday. In sign charts, once you've done the whole, find the critical numbers, the discontinuities, put them in a number line. I should have switched that order. Plug into one test value for each interval. Plug into the first derivative. Check the sign. Figure out whether f is going up or going down based on the sign. There's one more thing we can then say. Where the relative extrema are. It's nice and chilly. Where the relative extrema are. And even though it logically makes sense, there technically is a test that allows us to make the conclusions that we made at the very end of yesterday. And it says, as long as x equals c is a critical number of f. Remember, to be a critical number, the function has to exist there. It can't be a vertical asymptote or a hole. That's not going to work out so hot. But as long as x equals c is a critical number of f, if f prime changes from negative to positive at a point, f is going to have a relative, as you don't just have to memorize the words, think about the idea. If f prime goes from a negative slanted tangent line to a positive slanted tangent line, what has to be in between? Min, right? A min, that means a relative min or a local min. If you have a negative derivative to a positive derivative, where it changes has to be a min, as long as it exists in the critical number. And if f prime changes from positive to negative, there has to be a relative max at that point, as long as it's a critical number and exists in the original function. And if f prime doesn't change sign at a critical number, then that critical number is not a relative min or a relative max. It is neither. If you need to, you can think of it. If f prime changes from positive to negative, that means f changes from increasing to decreasing, right? Isn't that what f prime positive to negative means? F prime positive means f is increasing. F prime negative, f is decreasing. At a little point C, and it could be a sharp point or it could be a rounded point, but it has to be a point that exists from the beginning. And if f prime changes from negative to positive, remember what that means? F is changing from decreasing to increasing at a point C. It could be rounded, it could be sharp, it doesn't matter. That's going to be a relative minimum. So yes, there are lots of words to memorize, sort of, kind of, maybe, but it's more of an idea to understand. And yet, I'm still going to go ahead and zoom out, get a rounded rectangle, burp, and make it yellow, because I'm putting in a what? Mm-hmm. And I believe this is forever number 25. I'm moving everything but what I want to move. Hold on, let's try. Okay, there we go. Forever number 25. I think the final forever of this section is. I know. To that end, kiddos, we've had a few forevers, yeah? We've had a few forevers. You better get a forever quiz in, or else it's just going to get worse as we go.
Yeah.
So I already announced it to period 6 yesterday. We kind of were talking about it. They didn't want it tomorrow. They didn't want it today. I wouldn't have it today anyway. We all figured, well, not we all, but all the smart ones, we figured that Monday would be a bad day. So therefore, forever quiz is going to be on Friday. If we do Tuesday, you're going to have even more. That's not very smart. Once again, all the smart ones agreed with me that Monday was a bad idea. There was like one person that said Monday. Yeah. I meant to do it yesterday, just so, but there was some fun going on yesterday, so I'll do it then. But remember, they're also marking us. But yeah, I'll get them updated online today. Okay, real quick at the very bottom. I've kind of mentioned this a few times, but just a reminder because I've seen a lot of calculus kids come through and I've seen a lot of mistakes been made, yeah? And one of those common mistakes is why this reminder has been written into the notes in the last few years. Reminder. F has to exist at that point. No discontinuity. So F does not have to be differentiable at that point. It could be a sharp point. What does this mean? This means to be a relative min or to be a relative max, F of C must exist, but F prime of C might be undefined. Some people get really confused on that one. In order to have a relative min, that's not a part of the forever card, it's extra. But in order to have a relative min or relative max at a certain x value, the original function has to exist at that x value. If you have a vertical asymptote, he cannot be a min or max because he's not existing. Same thing with a whole. In order to have a max or min, the original function has to exist, but the derivative might be undefined. The derivative is allowed to be undefined because we're allowed to have a sharp point, but the original function has to exist there. Okay, so how do we do this? How do we use it? How do we work it out? Let me go ahead and dual page. I think I have an example. Oh, I don't. Struggle. Let's just go to an example. No, that doesn't work either. Here we go. What is that? That's not my phone. Ooh. I don't think you guys need to write this down, only if you want to. I forgot before an example I technically, like the last one I did with this whole steps. And make sure you do this and this and this and this. But what do these steps say? How do we do the whole first derivative test to find relative extrema? We do all the same steps as the other increasing, decreasing sign chart. So we do an increasing, decreasing sign chart with the pitchfork and the critical numbers and the discontinuities. And then what do? What's our one added step for?
Analyze sign chart for relative extremity.
Yeah. What does that mean?
Wherever it goes positive.
Yeah! See if there's a change. And if there's a change, make sure that point exists and say, ooh, yeah, I found a relative min or I found a relative max. If you want to write that, you can write that. Charlie, you like that? Mm-hmm. Let's not do the whole one, because that's just never a good sign. Okay, let's keep moving on. You don't necessarily need to write this either, but what am I trying to prove on this page? Relative mins and maxes, but to have a relative min or max, what has to happen with the first derivative? Okay, do you see the difference between when a relative min or max happens and when neither happens? This one. What are the tangents before? Negative. What are the tangents after? Positive. So the derivative before is negative. The derivative after is positive. There's a horizontal tangent, a critical number in between. That has a min. Sines, tangent lines are positive. Sines of the derivative are positive. Tangent lines are negative. Sines of the derivative are negative. We have a zero of the derivative in between, a critical number. That's a relative maximum. So why do both of these fail? Do we still have a critical number? Yeah. Do we still have a critical number? Yeah. But what's the sign of the derivative before? Positive. And after? Is that a relative max? No. Do a little circle and say, is he the highest? Not really. Right? What's the sign before? What's the sign after? If I were to draw a little circle, question, is he the lowest? No. Nothing exciting going on, right? Okay, so let's take all that we've seen and let's go ahead and, booyah, there we go. Let's tackle these two problems. This is like the end of homework. Almost the end. There's like this application thing with motion at the end. End. Let's tackle these two. Now we're going to tackle them together. We're going to do it step by step. You guys do it on your own. You tackle them on your own in homework. Hopefully collaborating with some friends. You have some friends on in your contact list. If you want to ask the question, why is homework a thing? Jared Wire and Ryan Murphy help you out. Jared Wire asked the question. Ryan Murphy answered it. Plenty of sarcasm. A little bit of snarkiness in there. However, even with a joke, there is some truth. And there's definitely some truth in there, too. Let's just start with number one, shall we? I need you guys to participate. So if you're not participating, you're falling asleep, and I can tell because I see all these little eyes. Okay, ready? Our first step is just to do increasing, decreasing. So where did we start with increasing, decreasing? Number one. Check for discontinuities. Uh-oh, does he have any discontinuities? Yes. We can state them really quickly in the domain because it's just a domain problem, right? X is not equal to who? Plus or minus 3. Let's look at the denominator. We say he's not allowed to be 0, so X is not allowed to be plus or minus 3. Good. Number 2. Now what? Take the derivative because we're trying to get to who or what? The critical numbers, which you guys have been working on since section 3.1. Everything's building, hopefully in a good way. So, the derivative. You guys quotient ruling it? Alright. I'm just going to go through it and you guys can check your work, okay? Ready, set, and start to rhyme. Follow the rules. How are we looking? If you're not there yet, it's okay. Check your steps. Were you on the right track? 2x cubed minus 2x cubed, that goes away. Negative 18x. Got it, got it. That's the derivative, but are those the critical numbers? No, I have to do pitchfork, right? Pitchfork at the top. The top equals 0 when? The bottom equals 0 when? plus or minus square root of 9, which means plus or minus 3. Wait a minute, what's going on at plus or minus 3? Discontinuities. So I'm going to go ahead and put a quick line through those and be like, you know what? Uh-oh, we already got those. Technically, what's going on at plus or minus 3? Are they holes or vertical asymptotes? Por qué? Pourquoi? How come? Holes need to factor out, and those aren't factoring, right? We'll still need poor little kittens and start crossing stuff out. X plus 3x minus 3 does not match anything from the top. So not only do I have a restricted domain, but I have vertical asymptotes there. Okay, step number 3. I draw a sign chart, but that's just a snazzy name for a number line. And why am I having it go forever left and forever right? What's the domain of this function? Negative infinity to infinity, but what do I need to mark out? If you want, you can put a little dotted line by negative 3 and 3. It reminds you it's a vertical asymptote. It just kind of helps reinforce. Then I put a little 0 in it. You guys remember from increasing, decreasing, I put a little f prime on top and a little f on bottom because we're trying to figure out the signs of f prime to figure out the behavior of f. That'll help me out. I take a quick little time out away from that number line and I say, uh-oh, I need to start doing some testing. But who am I testing? Or what am I testing? The derivative. I'm testing into the derivative. I'm going to have to plug stuff in like, I don't know, like negative 4 maybe? Right? And I'm going to test something like, I don't know, negative 1 maybe? Couldn't it have been negative 1 or negative 2 or negative 2.765? But who wants to plug in negative 2.765? Not me. So I'm plugging in negative 1 instead. Just saying, you can plug in lots of things. F prime of 1 sounds good, and how about F prime of 4? Yeah. Is that okay? Move those down first. When we test, we're not looking for a number necessarily. We're just trying to check the what? Sign. So, has anybody thought about plugging in negative 4 yet? Yeah. Where are we plugging it into? Yeah, the first derivative, so we want to check the sign. So plugging in negative 4, let's see. A negative times a negative is a... Oh wait, the bottom squared, that's always a positive, right? So what's a positive over a positive? Got it. So in that interval, f prime is positive, which means f is behaving how? Increasing. Okay, how about negative 1? Yeah, because a negative times a negative is a positive. This bottom part is always positive. It's being squared. So therefore, all right, fine, that's positive also. So therefore, my function is still doing what? Increasing. Going up. Plugging in positive 1. Uh-oh, a negative times a positive is now a negative. A negative over a positive is a negative. Plug in 4, same thing, right? A negative over a positive is a negative. What's going on with my f if the f primes are all negative? Decreasing. Now technically, we might be able to, with just a little bit of pre-cal, get a pretty stinking good picture of what this looks like as a vertical asymptote. He's increasing, decreasing. He's increasing, increasing, decreasing, decreasing. This is kind of weird. The good thing is we're not supposed to be getting a sketch yet anyway. All they're asking us is, when is the function increasing or decreasing? Just kind of reinforcing that really quickly. Increasing is going to be negative infinity to 0, right? No. Where do we need to split it because the function doesn't exist there? Good. It does increase all the way to 0, but we have to cut it up at negative 3 because that's a place where the function doesn't exist. But the nice thing is, doesn't my sign chart show me that? Negative infinity to negative 3 is 1, negative 3 to 0 is another. What's going to be my decreasing intervals? Exactly. 0 to 3, and 3 to infinity. Now, what if they're asking me for relative mins, if any, and relative maxes, if any? Yeah, any relative mins? I'm hearing you guys say it. Are there any? No, because do you see anybody swooping up? Me either, right? So relative mins, none. And relative maxes, I heard you guys say one. Where is he at? And if they wanted the point, if they wanted the point, wouldn't they want the x and the y? So we have to go back and plug in 0 to the very, very beginning. If they wanted the actual point, plug in 0 with 0 for anything. 0 for any number, which we have. So question, kiddos, to get our relative max, do we really have to do that much more work? Or did we just kind of tack on one extra step? We just said, hey, now we look at this thing and say, okay, look, I see you going from up to down. You're increasing. F is increasing to decreasing because F prime is positive to negative. And 0, I try to plug it in. He works. Cool. He exists. Therefore, I have a relative max at 0. Kiddos, this is section 3.3. We're going to do some more examples, but this is it in its entirety. We're just looking at increasing, decreasing nature of functions and what they mean in terms of relative extrema, relative mins, and maxes. Now, I do have another one. Why does he look a little scary over here on this side? Oh, he's piecewise. Okay, give me 1 second in order to quickly do a little condensing over here. Boop. Just to make sure we have plenty of room. But guys, what's the very first thing that you should be thinking about anyway as we go to a new example? Check for, say it louder, discontinuities. Uh-oh. How do we check for discontinuities of a piecewise? Whoo, we got to look at the separator, yeah? Come on, AP number 1. We've been going over this idea the last few days. Does he have any discontinuities on his own? No, no denominator, square root, logarithm, trig. So much stuff being done on phones right now. Put them away. Does he have any discontinuities? No. No, he's fine, right? No denominator, no square root, no logarithm, no trig. But where could the problem be occurring? But we wrote this down yesterday. Do you remember what we do to check? He's a little f of x, he's a little g of x, and we're just trying to plug him in, and see if they're equal. So we say, oh, hey, for continuities, to be continuous, I double check and say, does 4 minus 0 squared equal negative 2 times 0? Well, we're not doing MBTR roles. But we did find a discontinuity. Where's the discontinuity? So since this is not equal, 4 is not 0, we're like, oh, he's not continuous. And where is he not continuous? He's not continuous at? So who is my discontinuity so far? 0. All right, step number 2. Now we need what? Critical numbers, the derivative. How do you take a derivative of a piecewise? Piece by piece, right? We're building a school. Piece by piece. We're deriving a piece by piece. Okay, so, how to take a derivative? You should get Mr. Striker. Yeah, what's the derivative of 4 minus x squared? Negative 2x, and that's for all x less than or equal to? I think so. What's the derivative of the second one? Yes. For all x greater than 0. Okay, we're trying to set this equal to, oh no, how do you, what? We're trying to figure out his zeros or his DNEs of the derivative. The zeros or the DNEs. We're trying to find the critical numbers. Okay, when would this derivative equal 0? At 0. Oh, okay, well that's kind of, okay, whatever, at x equals 0. Where does this derivative not exist? I don't know, he seems fine, he seems fine. What about the separator? We're checking if it's differentiable. If we plug in from the left, wouldn't that be negative 2 times 0? If I plug in from the right, isn't that negative 2? Oh, wait a minute, the derivative doesn't exist at 0 because what's going on at 0? They don't agree. There's a discontinuity of the derivative. So there's not a 0 at 0, there's a DNE at 0. But however you look at it, is there something going on at 0? Oh, but wait a minute. We already knew 0. Okay, well that was there's only one number we have to worry about. He was already a discontinuity, so of course he's going to be a non-differentiable point. All right, well, this is kind of lame. All we have to do in our sign chart is put a 0, right? So then, sign chart. Negative infinity to infinity, because this one says greater than 0, less than or equal to 0. It has all numbers. We're just putting 0 in, and somehow he's undefined. It's not a vertical asymptote. I won't put little dotted lines. I guess we could put like a little hole, just to be like something's wrong. It helps. That way you don't forget that something's wrong there. Okay. I need to plug in something before 0 and something after 0. How does f prime of -1 and f prime of +1 sound? Perfect. Where do I plug f prime of -1 into? The top piece, because he's less than 0. Ooh, the x is less than 0. So -2 times -1 is a positive. Oh. So that's going to be a positive, which means that's going to be a positive, which means my function is doing what? Got it. Right?
Plug it into the derived one.
Good. Because remember, I'm trying to check the sign. The derivative goes first, so I need to plug into the derivative, and that tells me how f. So then, plugging in +1, he goes in the other piece, right? And, well, that's always -2. Okay, fine, it's negative, right? So negative, negative, negative. What's the function doing? Decreasing. Oh, hey, there's a relative max where? Nowhere. Wait, but I see him. Why doesn't it work? Something's wrong at 0. The function, something's wrong at 0, right? So if something's wrong at 0, we can't call him a relative max. You see why we have to be super careful about discontinuities? In a normal function, you look and you're like, oh, I got this down. I'm looking at my sign chart, relative max, and I'm done. Why? Because there's something. Doesn't mean there can't be an absolute one, but we'd be doing a different test with a table, and we'd be putting in that table endpoints if there are any. There are critical numbers, and we could be figuring that out. But for relative extrema, none. That kind of makes sense why I say watch out for those discontinuities. Sign chart is going to look really good. Except for like, nuh-uh, something's broken there. Something's broken there. So you can't put a nice little circle and say, hey, from either side, this will be the highest. Okay? What if I was to give you this one? Ready, set, you guys, go. Come on, you got it. Oh, wait. Why not? They tell you it's continuous everywhere. Oh, number 1. Number 2, find the derivative. Do you have to do that either? Why not?
Oh.
They gave it to you. Oh my goodness, it looked nasty for a second, right? Okay, so step 1 is done. Step 2 is done. Now what? Sign chart. Oh, okay, we can't do a sign chart until we do critical points. So hold on. Did you guys find your critical numbers? What would they be? We know who f prime already is. We're just going to set, top and bottom equal to 0. Nah, there's no bottom, just the top equal to 0, right? Exactly. We have factors, separate pieces. You can put them in parentheses, so that helps. You can set x squared equal to 0, which will be when x equals 0. Square root equals times, right? Plus or minus 0. How do you set x cubed minus 5 equal to 0? Well, you just do it. Add the 5 cubed root, right? Since the cubed root, no plus or minus, he's just alone. Cubed roots retain the sign. What do I do with those two numbers? And the sign chart. So, I'm going negative forever to positive forever because this function, his domain is, well, continuous everywhere, all the numbers. I put in my 0. I put in my cubed root of 5. Ew, cubed root of 5. Isn't that something between cubed root of 1 and cubed root of 8? What's cubed root of 1? What's cubed root of 8? So it's somewhere between 1 and 2. Oh, whew, that's nice. So I can plug in a 1 and I can plug in a 2? Does that make sense? You don't have to know exactly who he is. You're just plugging and chugging. You just have to have like a general idea of who he is. There's f prime, there's f. Let's plug and chug. F prime of negative 1? You guys like that one? F prime of positive 1. F prime of 2. Is there anything magical about the numbers I'm picking? No. They're just in the interval. You could have picked negative 10 if you want. I don't care. They're all going to have the same sign as long as it's in that interval. Who are we plugging into? The derivative. This little guy. If I plug in a negative 1 squared is a positive. Negative 1 cubed is a negative 1. Negative 1 minus 5 is negative. A positive times a negative is a negative. Is this something you guys are going to have to be really careful of when you're doing it in homework or on a test? Yes. But can you do it? Yes. Just take your time. Figure out the sign. Plugging in positive 1. That's going to be a positive, and 1 minus 5, well, that's still a negative. Positive times a negative is a negative. Starts off decreasing, flattens for a second, and keeps on decreasing. How about when you plug in 2? 2 squared is a positive, 2 cubed is 8, 8 minus 5 is a positive times a positive is a positive. Alright, okay. Without even knowing the graph. Do we have any relative maximums? I don't see any of this going on. Do you? I don't. Relative maximum. But do we have any relative minimums? Or minimum? Well, we have 1. Don't they? There are no discontinuities. He's continuous everywhere. So this one, since I see the change, bingo, he's my relative min. I can say relative min at x equals cubed root of 5. Could I find the point on this one? Who don't I have to plug into to find the y value? Yeah, I have the original, so forget it. We're done. I'm done. Whew, that was rough. Did we make it? Okay, does it all kind of start tying together? Critical numbers from section 1, relative extrema from section 1. Increasing, decreasing sign chart from the beginning of section 3.3. How to test for relative extrema at the end. Uh-oh. Oh. Who's this guy? In exercise 77 to 82, the graph of f is shown in the figure. Sketch a graph of... let's come back to haunt us. Do we see these at the beginning of the year, kind of, when we first started talking about derivatives? We have an f, we need an f prime. Well, how do we do that? Kiddos, how's f behaving? Could we think of a little baby sign chart if we needed to? I'm splitting it up at 0 for a very important reason. We'll come back to it in a second. And couldn't we say, isn't f increasing to 0 and then increasing some more? Right? Isn't he increasing to 0 and increasing some more? Huh. So what are the signs of the values or the y values of the derivative? Positive. So he's going to be above, and he's going to be above. What's going on at 0? What's so special about 0? What kind of tangent line is that? And a vertical tangent line has what kind of slope? Infinite. Does a vertical tangent line exist? Does the slope of a vertical tangent line exist? What's going on at a vertical tangent line? A vertical asymptote of f prime. And what's happening to the slopes of the derivative? They're increasing. And what's going on to the slopes as I go this way? Getting closer and closer to 0. Oh, the derivative has a horizontal asymptote at 0 somehow. And then what's going on as I come this way? The derivative's going to 0 again. Oh, okay. The derivative's going to 0. On the positive side, he's above the axis. And what's going on to the slopes as they come towards the vertical tangent line? Steeper, 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 higher, 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 higher. There he is. If I'm trying to graph the derivative, I have to think about what are the slopes doing. Positive just means above the x-axis, they have positive y values. Increasing, he's going to keep on increasing, getting closer and closer to that vertical tangent line. Steeper, 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 steeper. Going to infinity. He's going to go steeper, comes from the right, and then he gets flat as he goes out, and as he gets flat, his values go to 0. We're going to actually work on this a little more with the overhead projector tomorrow, but for right now, let's go ahead and look at one more. Let's look at one more. How do you see it as a graph? The question, the graphs of this. F prime. Wait a minute. Wait a minute. Wait a minute. Why do we have a graph of F prime? Because the AP loves to give you something you're not expecting, although you should be expecting this by the time of the AP. Question. If I was to do a sign chart of this one, from the graph, do I know the signs of F or the signs of F prime? The signs of the derivative, that's the graph I have. But the signs, wait a minute, if this is F prime, am I looking at where he's going up, going down, or where he's positive or negative? Which one do I care about? If this is F prime, am I caring about his increasing, decreasing, or am I caring about his positive or negative? Yeah, the sign chart, F prime, goes with positive or negative. Positive means everywhere above the graph, the y values are positive above the x-axis, and the y values are negative below the x-axis. So question. First of all, where are the zeros of F prime, or the critical numbers? Wait, how did I find those? Did I go to mins and maxes? No. I'm looking for the zeros of the derivative. Where were the zeros? I was kind of zoomed out. Negative 1, 0, 1. What's the sign of the derivative before, from negative infinity to negative 1? Where is he? Above. So he's positive. What's the sign of the derivative in between? Negative, because he's below the axis. What's the sign in between 0 and 1? Positive. And what's the sign after to infinity? Negative. So what's going on with F, even though we can't see him? It's a question. How on earth can they ask me to look at a graph of a derivative and figure out where the relative extrema are of the original of a graph I don't have? Huh. I see him, don't you? I see a relative max where? Negative 1. There's 1, right? And where else do you see it? Positive 1. Do you see a relative min? Where? 0. And why does it make sense that an original function would have something just approximately that looks kind of quartic if its derivative is cubic? Power rule. To have a cubic derivative, you must have had a quartic to begin with, and if it's negative, flipped the wrong way, he must have been negative too. And all of that was looking at this, getting the sign clues, then thinking about how F is behaving. It's kind of crazy. It's a very AP-ish thing to do, and we'll practice it more tomorrow. Now, guys, listen. You don't have either of these homework problems in your homework. I decided to do the crazy graphy things on our own today, or with me today, I should say, all together today. So this stuff we're going to work on more tomorrow with the overhead and with another AP assignment, AP number 2. That's not just answering multiple choice questions, it's actually a card matching game that you're going to be able to do in groups and in partners. Before tomorrow, think about 3 people, hopefully. 3 to maybe 4. I would prefer 3, but maybe a couple groups of 4 just because of numbers. Groups of 3 to 4, come ready. It could be in this class and a mix with period 6. I don't care because I have all you guys. Does that sound good? But come with a group of 3 or 4. If you guys want to talk about it for the last minute or so of class, that's cool. But homework. I want it fully attempted by tomorrow, but we're not checking the evens until Friday. Sound good? Yes. Okay, now hold on, wait. Those of you that procrastinate, you don't want to procrastinate this morning. Start on it. Little by little. So I'm saying do as much on it tonight as you can. Come tomorrow, we'll reinforce some ideas. We might even get some people to the boards tomorrow with tricky ones. Odds and or evens, that'd be nice, right? So we're going to talk about an AP assignment. You guys need to have a group of 3 or 4. from either of the classes combined. And if you want to, you can talk in your groups and be like, hey, do you have an extra spot? And if worse comes to worse, I can kind of mix you in or put you in a group by the end of the day. But we're going to talk more about this crazy graph stuff, and I've been telling you I'm going to help you on it, and that's going to start tomorrow. Sound good? All right, cool kids, talk about things if you want to. Otherwise, wait to the bell. Wait to the bell. Bye.
Just staring.
Right here, a whole minute. All right.
Yeah, I'm trying to write it down so I can send it. I'll just stop. I love my
That's not a trash can, Ella.
Yeah, you can check. It'd be up there if I had one. It's warm and toasty.
Really not there, it's really funny.
Yeah. Thanks, Justine.
You're welcome.
I was being